Yeah. Hello everyone. So far so good. We have discussed about very basics of blockchain, like how the blockchain will work and how what are the key components in the blockchain, and also we have discussed about different types of the blockchains, public and private, and also um, models, blockchain models based on the database like account model and UTXO model. So these are the basics which we covered in the very basic session. In the next sessions, we have covered the basic cryptographic concepts required for the blockchain, like cryptographic hash function and how the Merkle tree will be constructed from the cryptographic hash function and the hash functions, properties of the hash function. And also we have seen some hands-on experience on that. Later, we have moved on to the digital signatures, which are very helpful in the transaction process in the blockchain. So we have discussed about about that also. Like signature schemes consist of three different algorithms. One is the key generation process and a signing algorithm and verification algorithm. So this will be very helpful while proving the authenticity of any user on the blockchain. So now we will dig deep into key concepts of the blockchain. So these are blocks. We will discuss about block. So what are the block contains and how the mining process will be done, how the mining process will helpful to add the blocks to the blockchain, and this mining process is related to the proof of work mechanism. Later we will also discuss briefly about the consensus mechanism in the Ethereum. Okay, so let's start. Here the key concepts explain a block structure and linking. So we will discuss about the block structure and also how the blocks will be linked to each other in the blockchain. Next, we will discuss about the mining process in the blockchain, which provides the security to add the transactions to the blockchain. And also we will see some basic Python at the end, and also we will simulate the proof of work mining process. So this proof of work mining is the process of linking the blocks, adding the new blocks to the blockchain by linking through the previous block hash. We will discuss detail about that in the next slides. And also we will compare proof of work and the proof of stake. This proof of work is a mechanism to add a new block to the blockchain in the Bitcoin blockchain, and proof of stake is the similar mechanism in the Ethereum blockchain, which is different. So proof of work depends on some computational work, which needs miners need to do some computation, which is cost effective, and which is very costly operation. So that we can avoid that by using the proof of stake mechanism in the Ethereum, so that it will be environmental friendly to avoid the computation process which consumes a lot of electricity in proof of work, so that we can compare both the proof of work and proof of stake mechanisms at the end. Okay. So as you already know, the blockchain is a linked list of the blocks. Like it will link the blocks from time to time. So for example, this block one, which is called the Genesis block. This is also called the Genesis block. Oh, sorry. Uh, just give me 1 minute. So this first block one is called the Genesis block, and which consists of there are a lot of metadata within that is the hash of the block, previous hash of the block, which is initially it is assigned to all zeros, and which is called the Genesis block because there is no previous block to the Genesis block. That's why the previous block will be made as a all zeros. And the hash of this block is consist of hashing, you know, the cryptographic hashing function, right? So that will be hashed, the block header will be hashed into h1. So we will see how in the next slide how it will be happen. So this block will be, and while creating the next block, which is called the block 2, the previous block is linked by adding previous block has h1 within that block. For example, in the block header of the block 2, we are including the hash h1, which is the hash of the previous block. Similarly, In the block 3, we will include the previous block hash h2, uh, which is calculated from the previous block called block 2. Similarly, the blockchain will be extended by including the previous block hash. This way, the blocks are linked to each other such that it is called a data structure called linked list of the blocks. You know the linked list in the in the data structures, like it is a data structure, data structure in the sense which will be helpful to store some data. So you know, the basic data types in the block in any programming language, not in the blockchain. Can you anyone, if know about the data types and data structures, can you please let me know? Otherwise I need to explain very briefly. Yeah, can you let me know whether do you know?
No, sir.
No, okay. So there are different types of the data structures. I will take a new. So in any programming language, there are different kind of the data types. For example, we have an integer data type, which is used to store integer values. For example, if we define in C language or any language like int a equal to some 10, so we will write something like that to store some value. So a will store some value, some integer value, something like this. Similarly, we have other kinds like float, which will be an example like float be equal to some 6.5, something like that. So it is some fractional values, it can store the fractional values also. And also the character and string. Character is a value which can store a single value, but this one can store, for example, string variable in any language can, for example, if we store s equal to some blockchain. So this is a type of kind of a data type which can store a complete a string. So this is a kind of the data types we have, and also other types like arrays. Arrays means it can store a group of data which can be in the memory. It will be stored in the sequential order. For example, if we define a of 10 equal to some one sorry, something like 1 2 and so on up to 10, this can store 10 values in sequence order. So every variable will have some memory allocation in the, for example, it can store 1 2 up to 10, 9, something like that. So there will be some address, memory address, something like 1001. So it will, so it has different storage capacity in different languages. For example, in the C, the integer values will be of uh, it will store around 2 byte. It will occupy 2 bytes of the data, and it will be something like 003, something like it will be 100, uh, it will be 19, something like that. So this is the memory addresses. It will store something like this, and also it can store the all the data within the stored variable in the sequential order. And again, if we take um, a linked list, linked list is a kind of the array. For example, it has two data. One is the value and another one is the address. Address of the next location. For example, value is 1 and next location is 002. Then in the next location the value will be 2. And that location again it will store the next location as 004. Similarly, this is the location 100 and this is the location 1002. This is the location 1004, something like this. So next value is 3 and the next location it will store is 006, something like that. So it is storing the next address value, but in the blockchain what will happen, so it is linked to something like this. It will link to next address through this address. So this is storing this value, address of the next value, and this is also storing the address of the next value. That means it is linked to the next address. It is linked to the next address, right? So similarly, in the blockchain, we are having the previous, instead of next address, we are storing the previous address. So here each block will consist of a parameter called the previous hash, which stores the hash of the previous block. That's why it is called a linked list of blocks. So it is the chain of the blocks which is linked through through hash value. That's why it is called a linked list of the blocks. So is it clear, or do you have any questions here?
Yeah.
Okay. So what each block consists of? So here we have defined the chain of the blocks, right? So each block consists of a block header. It consists of the two parts. One is the block header, and the next thing is the list of the transactions, which is called the body of the block body. So a block header consists of different parameters. As we have already discussed, it consists of the previous block hash, timestamp, nonce, Merkle root. So all these values we have already seen. This nonce value will be helpful in computing the proof of work. And Merkle root you have already seen in the previous section, previous session, like computing the Merkle root of all the transactions. So we combine that four transactions into a Merkle tree, and finally it will calculate the Merkle root at the top. So at the top, that Merkle root will be stored into the block header, and this previous block hash is the previous block hash of the previous block. For example, in the block 2 we have stored the h1, which is the previous block hash, and also the timestamp. Timestamp is the time at what at the time at which that block is created. The timestamp is calculated in terms of, as we have discussed in the first session, the timestamp is a parameter which computes the current time in seconds from the time 1970s 1970 January. So it will calculate 1970 January 1st as at 12 a.m. as a 0 second, and from that 0 second to the current time, it will calculate the number of the seconds computed from 1970 January 1st at 12 a.m. to the current second. So that is the timestamp which will be included within the block header. So the list of the transactions, you have already seen there are different types of the transaction models, like we have account model, and also we have the UTXO model. So in the UTXO model, we will have inputs and outputs. We will see how that will be, we will see that in the next session. Yeah. So this is the header. We will define the header consists of the version of the like currently, for example, if any changes has happened to the block data structures or anything, it will it will be added as a hard fork. Like though, so from for example, at block number 1 lakh, it will be included a new features to the blockchain. That new features will be considered as a next version. So for example, in the initial it is version 1. At some point of time, there are some modifications has done. At that time, that modifications had been included into the blockchain. That is be considered as a version 2. So it will be each version will be included at the when and where when we will change any modifications to the blockchain. So this time is the timestamp and time, and also this hash previous block, which we have already seen. These are the number of the bytes required for each data field. So n version is a 4 bytes, n time is a 4 bytes, and hash previous block n bits, n nonce, hash Merkle root. So here the n time, we will discuss about the n time. So here n time is not a timestamp. N time is at what time we can okay, so we will see that timing, we will see that end time in the proof of work computation. Okay. So here, how the hash will be calculated? The hash of the previous block. This is the previous block, and the right left hand side we have a previous block, and the left hand on the right hand side we have the current block. So the previous block, all the block header values will be concatenated into a single value, and it will be hash. Double hash means hash will be computed two times. First, it will compute one hash by adding all these parameters, like for example the hash of all these parameters, n version concatenated with n time concatenated with all those values, and again at the end nonce value. So this will give some value called some x. Again this x value will be hashed, will be computed y. So this is a double hash. Double hash means first it will hash one time by taking all these parameters, and output of that will be again hashed into final hash. That is called the hash previous block. So this hash previous block will be included in the current block. So the previous hash of the previous block will be included in the current block. That is the mechanism blockchains will follow. So we will see about the proof of work. So proof of work is a mechanism to, so you have some question now. So we are see we have been seeing blockchain is a chain of blocks, means list of the blocks which are linked to each other. So how can each block will be generated? So what is the mechanism used in the Bitcoin blockchain to add a new block? For example, currently we have 100 blocks. We if we want to add 101th block, 101th block, how can the process will include the what process is used to include that new block into the blockchain? So there are different number of the nodes in the network, right? You have already seen there a blockchain consists of a peer-to-peer network. So there are multiple parties in the network involved. So this is the about the database. What we have talking about now, like blocks, transactions, and the data structures. What are the data structures used in the blockchain? Those are the database that will be stored at each node. For example, here we are five members. If we five members are running a blockchain, so each one of us are a node in the blockchain. This is so we will connect through a peer-to-peer network. Peer-to-peer network means one peer to other peer. For example, I am a one peer, and you all the four will be other peers, like peer one, peer two, peer three, peer. Like we will have some notation for each and for identification purpose, and we will have the database. All these blocks will be stored at our own system. We all are maintaining one system, like one PC or one laptop or one high-end GPUs for running the blockchain. So we will have some database in our computer, and we will store this database in on our own computer. Like each one of us will store all these blocks data on our own computer. Like so each computer will become a one node. So For example, we have already 100 blocks passed into the blockchain. We all has already stored 100 blocks in our own computers. That is already done. So if we want to add a new block, we need to compute each other. So for adding each block, we will get some rewards. For example, if I want to add a new block, I will if the new block will be added by me, I will get some rewards in terms of the bitcoins. Suppose if someone Aishi or Manat if has added a new block, then you will get the rewards. So for getting the rewards, you will compete with each other. We will compete each other in the network. Like so, there is a benefit of adding a new block. For adding a new block, we are getting benefit in terms of the rewards. So for getting the rewards, we will compete each other. So we will compete in terms of some computational puzzle. So that computational puzzle is called the proof of work. So we will all try this computational puzzle. Once this puzzle, whoever solve this puzzle first, then he will send that block to the network. So everyone will receive that block. Once everyone will accept that block, then the person who added that block will get some rewards. That's why all the parties or all the peers in the network will compete each other to find a new block. The finding a new block will be happened through this proof of work mining process. So how this proof of work mining is a puzzle. It's a mathematical puzzle. Just think as a mathematical puzzle. Whoever solves this mathematical puzzle first, then he will add the result of that puzzle into the block, and he will broadcast the new block. Once that new block is accepted by everyone in the network, then he will get the rewards. So how this mining process will be happened? So this we already seen. We have hash previous block in the block header, and also the hash Merkle root. Merkle root. This previous block is a double hash of the previous block header, which we have already seen in the previous slide. So we will double hash the previous block header, and we will include that into the hash previous block field of the current block. Okay. The next thing is hash Merkle root. You already seen in the previous class, like Merkle root is the combining all the transactions into a Merkle tree and constructing the Merkle tree and also computing the Merkle root by that, which is the end point of that Merkle tree. You have already seen that Merkle tree in the previous session, and also I have given that Merkle tree in terms of the assignment. So, and we have another field called the n bits. This n bits is a target value. So this target value consists of some value. It is a 256-bit value. We have already seen how the binary is converted into the hexadecimal, or decimal will be converted into the hexadecimal in the previous session. So this is a big number which is called 256-bit number. It is very difficult to remember that number. That's why we will represent all the values in terms of the hexadecimal. So this is a target value. This n bits value is a target value, which is also included in the block header. This target value will be used in this computational puzzle. So how this will be done? So here we are computing the hash, right? So in the previous, how the computation of the hash will be happen? It is through the double hash. Double hash means including the hash, including the all the values of the block header and first time into the computation of the hash. Then the result of that, which is called x, is again hashed with the hash function to get the final hash value y, right? So here this puzzle will be something like this: double hash SHA-256 of n version hash previous block and n nonce. Here the value n nonce is a variable. All values will be fixed. So this puzzle, how this puzzle will be worked? This puzzle will be worked by fixing all the other values except this n nonce, which is at the end of the this line. This n nonce is a number which is 4-byte value, which will be variable. And for example, this puzzle, this problem, this will be start by everyone in the network, and whoever solves this puzzle, for example, he will start with the nonce 1, and he will compute double hash, and he will check with target value t. If this condition satisfied, then he succeeded in this puzzle. If this condition doesn't satisfy, for example, if the double hash of all these values greater than t, then he will change the n-nonce value. So for example, in the beginning n-nonce value is 1, then he will change the n-nonce value to 2. Then he will again compute this double hash, and again he will compare with the t. So once if it is works, then he is succeeded in the puzzle. Otherwise he again change the value of the n-nonce to the next value, he will change to 3. If he succeed, he will broadcast. Otherwise he will not, he will go to the next value of the n-nonce. Next value is 4. So what he will do, he will repetitively compute this function by changing the n-nonce value, so that it needs to satisfy this condition of calculating the double hash should be less than this target value t. So he will work on this computational problem until he satisfied this condition. So he will change the n-nonce value and he will check the value against the t. So he will do repetitively this step to get this condition success. Otherwise he will repeat again. So this is the mechanism of the proof of work. So he will compute this double hash and compare with the t by changing the n-nonce value, and until unless he will succeed in the problem. Whoever succeed in this problem first, he will include this n-nonce value into the block. So we have the n-nonce value in the block header, right? This n-nonce value is not fixed at the beginning. He need to solve that problem. Once he solve that problem and he need to fix that final value into this block header, then his block is ready. Once this n-nonce value is not ready, he cannot put n-nonce value randomly. So for example, I will take some random n-nonce value and I will include and I will broadcast the block, and I send the block to the network like, I have this n-nonce value, please accept my block is not please accept my block, and I will say please accept my block to the all other members, but they will not accept, because if they need to, if they need to accept, this need to satisfy this condition. So they will again verify it. So if I pass that block to the network, to all the members in the network, then again verify this condition, they will include the n-nonce, they will calculate this double hash and with that n-nonce value, and they will check this condition. If that condition is not satisfied, they will not accept my block. Once this condition is satisfied, only they will accept my block. That's why I cannot put n-nonce as a random value into the block header. So I need to compute first, then only I can include that n-nonce value into the block header. Until unless it satisfies this condition, that block is not accepted by all other peers in the network. Okay, so once I solve this puzzle, only I can include that n-nonce value into the block header, and I will send that block to the network. So here the n-nonce corresponding to the above puzzle is considered as a proof of work. What is the proof of work means? Solving this n-nonce value is called a proof of work. Solving this n-nonce value for this uh, inequality condition, so is called the proof of work value. So this proof of work is difficult to generate but easy to verify. So for computing this value, he need to check each and every value of the n-nonce. So I will start from n-nonce equal to 1, 2, 3, 4, 5 until it consists of 4 bytes. 4 bytes means 32 bits. 32 bits means I need to solve for 2 to the 32 minus 1 values. From 1 to 2 to the 32 minus 1 value I need to solve. In between I can get any time, I can get anywhere, I can get this condition satisfied. So once I get n-nonce value such that it satisfies this condition, then only I can produce a new block. Otherwise it is not possible to accept by all other members. So that's why it is a difficult to generate enhanced value, but verification is very easy. So if once I include the computed enhanced value into the block, then all other members in the network, once they receive my block, they can easily verify this condition by computing this double hash and using this enhanced value which I provided in the block header. So that's why it is difficult to generate but easy to verify. So this is the very important concept in the Bitcoin blockchain, which is called the proof of work mining, which is helpful to add a new block to the blockchain. So do you have any questions here? We will discuss now itself, and we will otherwise we will forward to the next topics. Yeah,
It's all okay.
yeah, thank you. You, Manat and Aishi, do you have any questions?
Yes, so we can move forward.
Yeah, thank you. So we will see how hard it is, how difficult it is. We said that it is very difficult, right? Proof of work is very hard, but how difficult it is. So you know the probability theory, right? I think in very basics in your class 11 or 12, very probability of success. For example, you have an event of tossing a coin. If you toss a coin, there will be a chance of head or tail, right? It will be 50% of getting head, 50% of getting tail. So that is a probability of 1 by 2. Probability of getting head is 1 by 2. Probability of getting tail is 1 by 2. Here the same thing. We will this hardness we can compute in terms of the probability. So if probability is very less, that is very hard problem. If probability is very high, that means very high chances of solving that problem, right? So for example, this target value is something like this: 7f all these values. So 7f means I will show in terms of the bits. 7 means it will be 0 1 1 1. So all other values will be 1 1 1 1 1 1 1 1 1, something like that, 1 1 1 1 1 1 1 1. So okay, so we have only 1 0 at the beginning, right? So you have a value which is very large here, right? Very large value. T value is very large in this case, large T value. So you have a range from 0 to T. So T is very large, and so what happened here? So you need to solve a problem. That problem, for example, double hash sha of something. So you are getting some x value. So you need to solve x should be less than or equal to t. Okay, we can we have already seen it as a y, right? So we will consider it as a y. So y should be less than or equal to t, right? You need to get this value, right? To get success in to succeed in this computational problem, you need to get output y such that y should be less than or equal to t. So if t is very large, getting y less than or equal to t is very easy, right? So you think about this puzzle as a some tossing coin, okay? So you have so instead of having only heads and tails, you have multiple values from 0 to t. So if you toss that coin, which is having the multiple values on the coin, it has some different faces like this side, that side, that side. So if you toss that kind of value, you will get some value which is less than t is very easy if t is very large, right? So that's why that probability here only two values, two success is two values. For example, this is zero, all these values. If tossing a coin is greater than less than if last value 0 is 1, if last value 0 is 1, then all this value will be all ones, that is greater than t. This is greater than t. So only one value is greater than this t value, right? So if you toss that coin and if you get this all ones value, then you will lose the puzzle, you will lose the game. So you will lose the game means the probability of losing the game is only half. So so you are getting some value which is greater than t is very less. So the probability of the value t greater than t is half, and the probability of the value y is less than t is only half, which is 1 minus 1 half. So that's why if it is only 1 0 at the beginning, you will have 1 by 2 is the probability of succeeding in this game. For example, if you have two values, that means you have here all zeros, like it is 0 0 0 0. Here only 0 111 means only one zero. Here you have four zeros. That means you have four different possible values. That means four you can for with these 2 to the 4 values are different. That is 16 values. So if among these 16 values, if you get any one, if you the probability of the success will be depends on these 16 values. That's why the probability is 1 by 2 to the 4. Similarly, if you increase the number of the zeros, the probability will be decreasing 2 to the 16. If t is again increased to 8, or it will be some 80, difficulty will be 1 by 2 to the 80, something like that. So the difficulty of the solving this puzzle depends on the number of zeros in front of the target value t. So yes, that's why this probability of the difficulty will be calculated in terms of this. So if the probability of solving this puzzle that is less than or equal to t is the t plus 1 divided by 2 to the 256. So if t value is more, t value is large, then for example if t value is in the beginning, like t value is 7 all f's, then probability will be this one divided by 2 to the 256. This will be around 2 to the 255. This value will be 2 to the 255. So that means it will be 1 by 2. Okay. And also if t value has four zeros, this value will be 2 to the 252 by 2 to the 256. That will be 1 by 2 to the 4. That is 1 by 16. That is the second example. So this is the difficulty will be decided. So if increase more number of the zeros in front of the t, then the difficulty is more. If we reduce the difficulty, then difficulty will be very less. Okay. Do you have any questions here? Yeah. So this entire problem is depends on the nonce and the difficulty. The nonce is number used once, and minors vary to nonce to change the block hash. This is all the theory which I have already discussed in the previous two slides. So and also the goal is to meet the difficulty levels, that leading zeros. That difficulties depends on the leading zeros. If the leading zeros are more, the difficulty is more. If the leading zeros are less, the number is very big. In the very big range, to calculate the t value, to calculate the final output which is less than t is very easy. So the difficulty depends on the leading zeros. Example, nonce value 42 means hash will be something like this. Nonce value 43, the hash will be something like this. So this all we have already discussed in the previous session. T is the number of the leading zeros, and also the example target value is something like this. This is the for this the probability will be 2 to the 4. There are 4 leading zeros. That means 1 by 16. So this is adjusted periodically. That means this value will be adjusted periodically for every 15 days. This t value will be changed for every 15 days. That means if the difficult, for example, this t value will be fixed such that a new block will be generated. So solving this, the new block will, the time of creation of the new block will be depends on computing this problem, right? So if the difficulty is large, the computational time will be very large. If the difficulty is less, the computational time will be very less. So if we change this t value, the difficulty will be changed. So this t value will be periodically changed such that the average, the 2 weeks average, it will generally it will take average of the blocks for the 2 weeks. So for 2 weeks, it will be around some every day it will generate 140 blocks. 140 into 14, it will be around 14 very 140 blocks per day into 14 days. So for these many blocks, it will calculate the average time for each block generation. So that average time is large, then t value will be reduced. That average time is low, then t value will be increased. That means leading zeros will be increased. So based on the average of 2 weeks blocks, the t value will be adjusted for every 2 weeks. So this is the entire mechanism which we have already discussed in terms of a block diagram. So we have the block header plus nonce. A block header consists of the nonce value. So here it will be double hash, not single hash. This is double hash. Double hash will be calculated of with this in input value. Then it will check whether that hash value is less than target or not. If yes, block is accepted. If no, and nonce value will be changed, and again compute the SHA-256 of that input, and again it will check the condition. Then again it will check if accepted. If this condition satisfied, then it is accepted. Otherwise, it again do by incrementing the nonce value. So this process will be repeated until unless we get this condition satisfied. This is the proof of work process in very simple diagrammatic way. Okay, so we will move on to the next thing. Like as I have already told, for every 2016 blocks, that is 2 weeks. In the 2 weeks, so in the Bitcoin blockchain, the block generation time will be 10 minutes. It will take it as a 10 minutes. The target value is decided so that all the nodes in the network will create the block within 10 minutes. This will be hard coded in the beginning so that the t value will be adjusted, so to make the average value should be 10. If the so it will calculate the number of the seconds taken to mine last 2016 blocks. That is for overall the 2 weeks, how much time it will take. It will calculate the average number of the seconds to calculate, and also it will calculate recall the probability is t plus 1 by 2 to the 256. For example, if the t sum, that is the average number of time, that is the time required to calculate the 2016 blocks, then the new value, that new value will be uh, this one. That new value will be decided by this last t sum. For example, if 8 seconds, it is 8 seconds, then it will be, in this case, how it will be 2016 into 8 into 60, but the actual decided value is 10 seconds, right? 16 into 10 into 60 of t value. This will be, if we solve this problem, 4 by t. Similarly, if this exceeds the 10 minutes, for example 12 minutes, then the new value will be 6 by 5. This is 12 by 10 into t, 6 by 5t. So this is the adjustment procedure. This t target value will be adjusted something like this by calculating the time taken for the last 2 weeks blocks. In the 2 weeks, it generates 2016 blocks. Is it fine?
Yes, sir.
Yeah. So this is the just how to implement the blockchain in the Python. So you can try this in the code. I will share this uh, document to you after this class. So you can try this, how to create a, you already have the Python coding experience, right? Can you let me know how you feel about the Python programming from the last session and from your assignment? So can you just briefly explain how you are feeling? Are you feeling comfortable with um, doing programming in the
Yeah,
Python?
that assignment was quite easy.
Okay. And are you comfortable to write the code which I have given in the assignment?
Yeah, I can do that.
Okay. So Did you tried any new coding with the Python apart from
Uh,
this assignment, right?
no, I just did the
Yeah,
assignment.
you have understand, right? Did you understand the basic data types in the Python and how to do the computation? For example, in the example which I have given a sine wave example, right? So in the sine
Yeah.
wave, it uses a inbuilt function like sine np that will be existed in the NumPy library. So we have defined that NumPy as np. So np dot sine will give the sine output. So that way, that is the computation. That is the functions required to compute in the Python programming. Similar kind of the functions. There are a lot of functions in the Python. Similarly, we can use Python for generating this procedure, this nonce value. So we have the hash. I have already given the code for the hash function, right? How to compute the SHA-256 value. So you can try by computing the double hash and also by comparing with this condition and by increasing the nonce. You can write a loop for loop. For example, nonce value will start from 1 and it will end with 2 to the 32 minus 1. Then you can run this loop so that whenever this satisfies this condition, then that will be block is accepted, otherwise it's not accepted. So you can write it on your own. I will give the code assignment after this session. So similarly, you can define the block. So it is a class. Class is something like it's a data structure which consists of both the data types and it consists of the variables and also it consists of the functions. So here there are a lot of functions we have defined: calculating the hash, mining the block. Here we have given how to mine this procedure, how to mine the new block in the Bitcoin blockchain. So here we have some defined initial values. So we need to give we need to give the index, timestamp, data, previous hash, all these values in the init procedure. If we instance in, so this class is a some characteristics of something. For example, you or now you have, right, you have some character, you have some characteristics, some parameters like you have some name, you have age, you have some what class you are studying and your hobbies, your games, or what. So many things are there. While so you have we have defined some parameters for you or some characters of you defined in terms of some class. So for example, class block will consist of these parameters. These are the metadata, and also it needs some functions to compute the proof of work mining. So and also these are the two functions: calculating the hash and the mining block. These are some functions defined here. So we can use this to generate a new block or to compute the proof of work puzzle. So here by how to calculate the hash. So here you have mining the, if you call this function, if you call this function, then you need to define the target. So this is just I have for understanding purpose we have given this here in this mining block. But this difficulty value will be changed every 2 weeks. It will be updated every 2 weeks based on the average time taken for the last 2 weeks. So here just we have hard coded as a only single zero, single zero, and we are checking this condition not equal to target, and also we are incrementing the nonce value, and we are calculating the hash. So calculate the hash value. So we are calculating the hash value by calling the another function called calculate hash. So it will go to this function calculate hash, and it will calculate the hash value by taking by concatenating all these values: index, timestamp, data, previous hash. By taking all these values, it will compute the double hash. Like first it will calculate the double hash. It will calculate the here okay, I need to change this code. I need to use the hashlib dot sha256 of hashlib dot sha256 of this entire thing. Okay, so this is the way to do the proof of work in the programming point of view. So you can try this code. You can copy this on the Jupyter notebook. You can execute this function on your own.
Okay.
Okay. So how to call this? So that is the functions defined. That is the class defined for that. For running the code, for running that simulation, you need to define. So first you need to define the Genesis block. Genesis block consists of Genesis block consists of index 0 and the timestamp time dot time will give the current time, and just data you don't have the data, but but in the real blockchain you will have the data, but here we are just keeping the data as a some string called Genesis block or block 2, something like that. And also we have zero value, nonce is zero, previous hash is zero. And we are doing mining the block by giving the nonce value as 4. um, Difficulty value as 4. It's not nonce value. We are giving the difficulty, passing this difficulty to this function mine block, and we are calculating that block. Then again we will calculate the next block, block 1. The block 1 index is 1, time stamp, and block 2 data, and Genesis block, Genesis dot hash. The previous hash is Genesis dot hash. Okay, we have some hash value within that. We will have the Genesis dot hash. So this way we can simulate the blockchain. So you can try this using the Jupyter notebook. If you have any questions, you can just mail me or message me by taking contacts from Devesh. Then I will explain you whenever you feel any difficulty here running this simulation process. Okay.
Yeah.
So this is the entire thing about the Bitcoin blockchain, how to create a new block in the Bitcoin blockchain by solving the proof of work computational puzzle. So do you have any questions till now? Just please feel free to ask. Otherwise, we will move to the, just we will take some 10 to 15 minutes. We will complete this consensus mechanism by discussing about a different consensus mechanism called proof of stake in the Ethereum. So in the Bitcoin blockchain, it is called the proof of work puzzle, proof of work mechanism. But in the Ethereum, it is different, which is called proof of stake. So we have, there is no miners, there is no computational puzzle in the proof in the Ethereum. We don't have the computational puzzle by changing the nonce value and by repeating the process until unless you will get the target value reached. Here we don't have such type of the computationally heavy problem, and it will reduce. So because of running that computational problem for 10 minutes on your own computer, and suppose for example if you have a 10,000 nodes across the network, and all these 10,000 nodes need to run this computational puzzle for 10 minutes, means it is very waste of the power. It will consume a lot of energy on your computer. Like you need to run the computer for 10 minutes for running that computational puzzle. So for running that computational puzzle, it will take a lot of computational electrical energy. So it will, so it is the way. But at the end of the, out of the 10,000 nodes, only one will be succeeded, right? So remaining 9,999 members will fail in that puzzle solving. So that is entire wastage of the electrical energy. So that is not cost effective. So that the people are thinking about this kind of the proof of stake mechanism to resolve that kind of the problems so that the Ethereum has chosen. In the beginning, Ethereum is also the proof of work, follows the proof of work mechanism, but around in 2022, I guess, in the 22 November, it was moved to proof of stake from the proof of work. Okay, so how this mechanism will work? The stake, it requires a stake. The name itself says it's a stake. You need to stake means you need to deposit or you need to invest. So you need to stake some money into this puzzle to become a new block producer. So here in the previous Bitcoin, the new block producer is called the miner. So whoever solves this mining problem, person is called the miner. That miner will get rewards after his new block included in the blockchain. But here we call the validators. The people are called the validators. So one of these validators will get rewards. That is called, one of these validator will get a chance to produce a new block randomly. This is a completely random process, right? This is a randomly chosen. For example, if there are 1,000 nodes in the network, each node need to deposit some currency. For example, 32 ethereum need to deposit to become a validator. So until if you don't deposit 32 ETH, you will not become a validator. You cannot participate in the consensus mechanism to generate the new block. So to become a member of consensus mechanism or to become a validator, you need to deposit 32 ETH into the network. This is called a stake. Your stake, you are staking 32 ETH. Your stake is 32, and other 10,000 members will also have their own stake if they want to participate in the in the consensus mechanism called the proof of stake. So you need to deposit. If even if you are running a computer by installing the Ethereum software and all, then you will not become a validator. You cannot produce a new block until unless you didn't stake 32 ETH. If you stake 32 ETH only, you are eligible to participate in the consensus mechanism to generate a new block. Until unless, you cannot become a validator. So if you have higher stake, for example, if you have 32 plus 32, if you have 32 ETH and again you deposited 32 ETH, you have two validators, right? So how many number of 32 ETH you need to you deposit, then you will have those many validators in the network. So you will have a probability of getting probability of proposing a new block, or probability of validating the block will be very high chances. If you have, for example, out of 10,000 you have 100 nodes, then you will get probability of 100 by 10,000, right? If you have only one stake, only one 32 ETH you have deposited, your probability of become a leader, or you become a block proposer, will become 1 by 10,000. The probability is less. So whenever you increase your stake, then you will get your probability of becoming a new block producer is called very high. So here the block producer means, here out of this deposited validators, randomly for every new for example, for every new round, so producing a new block is called a round. We will call it as a round time, will be some time duration will be there. So within the time duration, out of this 10,000 nodes, one will be picked to produce the block randomly. This is picked randomly. And another and remaining out of this 10,000, it will be remaining will be to vote on that block. For example, if we have 100 members in the network, so 100 members has deposited 32 ETH. So for example, at 100th round, randomly one will be chosen, because for example, Arnav has chosen as a block proposer at 100th round. Then he will propose his own block. Then all other 99 members will check the data of that block. For example, it will check the transactions, whether all those transactions are correct or not, and all the parameters included in that block is correct or not. It will check all the value, all the data, and they will vote on that block. All the 99 members will vote for that block. So out of the 99, if it gets two-third votes, then that block will be accepted. If that doesn't get two-third votes, then that block will not be accepted. Even if you are a proposer, for suppose Arnav has picked as a proposer at 100th block, he proposed a very malicious data or malicious transactions into the block, and all other 99 members will check that all those transactions, if those transactions are not valid, they will reject that block. They will not vote for that block. So if that block didn't get two-third votes, then that block will be not accepted. If it get more than two-third votes, then only that block will be accepted. Okay. So this is the selection mechanism. Entirely randomization ensures the fairness. This randomization, so this for every new round, a new one will be become, yeah, the probability of picking a block proposer will be depends on his stake. Suppose if you have one validator, you will be chances of 1 by total number of the validators. If you have two validators, it will be 2 by total number of the validators. If you have 100 deposits, 100 by total number of the validators. So if more deposits, more chances of getting proposal. Advantages is energy efficient. So like unlike previous proof of work, there is no computational puzzle. There is no energy consumed in this one. And also it is energy efficient. And also the faster block finality. So in the previous problem, they have fixed it as a 10 minutes. But here there is no need of 10 minutes to complete the complete block. It will be very fast, because the previous one also we can reduce the time, but if you reduce the time there will be more chances of malicious activities. That's why it has fixed as 10 minutes. So here the block finality will be very less. The major disadvantages is if you centralization risk. For example, if Arno has more money, he can invest more number of more ETH into, he deposited more ETH. For example, there are 100 nodes. Out of the 100 nodes, if 50, for example, Manat has deposited 30 nodes and 30 deposits, 32 into 30, and Arno has deposited 20 times 20 into 32 ETH. Then there is become a very centralization. Like out of the 100, you both itself is having 30% and 20% of stake within the network. That is very high risk. Like you will become you will become more chances of getting the block proposer, and you will, for each block proposer chance, you will get more rewards. So once you get a block proposer, you will get rewards. So your rewards will, your money will be accumulated, right? So if you have more money, more money will be accumulated in the network, and you will become very big power in the network. So that will become a centralization risk that should be avoided. So this is the main disadvantage within this. Okay. So how this work? So how this will be work? We will see in this format. We will complete in 5 to 10 minutes. So for example, participants will stake the ETH, and all these participants will be added to the pool. A pool will be created so that whoever deposits their stake, 32 ETH stake, they will be included into that pool. And after including that pool, in every round of the block creation, a random selection procedure will be there. He will be randomly chosen out of this. For example, there are 100 members in the pool. So out of the 100, every time it will pick randomly. For example, 11th one will become as a proposer. So 11th validator is picked as a block at 100th round. Then he will propose the block. Once he picked as a block proposer, he will propose the new block. Once the new block is proposed, and remaining out of this 100, remaining 99 are there, right? 99, that is 100 minus 1. Oh, this one will be the proposer who proposes the block, and other validators will vote on that block. If they vote honestly, the rewards, these voters will also be rewarded and the proposer will be rewarded. If they vote maliciously, they will be penalized. They will get some penalty. So they have already deposited 32 ETH in the network, right? Out of that 32 ETH, they will be network will deduct some money from their deposits. That is called slashing. So if they do any malicious activity, for example, if there are two block producers, for example, Arno has proposed a block at 100th round, then maliciously another, for example, for example, myself produced a new block maliciously, even though I didn't pick it in the random selection process. Then someone voted for my block also. Then that one will be For example, that person voted for two blocks, that one proposed by Arnav and one proposed by me. Then if Manat has voted for two blocks, Arnav's block and my block, then he will be slashed. He will be punished. The money deposited by Manat will be deducted. Some money will be deducted from the deposits. That is called the slashing. That is called penalty. So here the procedure is, once you stake into the network, you will be added to the validator pool. In every round, random selection process will be there. In every round, so that random selection procedure will select the proposer. That proposer will produce a new block. That block will be voted by all other members in the validator pool. This is the entire workflow of the proof of stake. Okay. Do you have any questions here?
Yes.
So this is already we have all discussed in the previous slides itself. This is just a basic comparison. For example, the proof of work versus proof of why. The consensus method is mining. You need to solve the puzzles. But in the proof of stake, the validators chosen by the stake, that is randomly chosen based on their stake. The energy consumption in proof of work, it is very high. In the proof of stake, it will be very low. Okay. The hardware required. So here in the proof of work, you need to solve a computational puzzle. You need very specialized hardware. So you need you need to invest some money in the hardware also, GPUs, ASICs. So this will be very costly. But in the POS can be done by the normal computers, normal standard computers also, because there is no computational problem involved here. The security is depends on the computational power, but here this depends on the economic stake. So if you stake more money, then there will be more centralized towards a particular person. That will be not, that will be a risk to the proof of stake also. So more if you so you need to avoid so more number of the participants need to be there in the proof of stake, otherwise it will be become centralized. So attack cost is 51%. So if anyone has more than 51% of the computational power, then they can easily attack. But here, if they have more than 33% of the stake, like for example, out of the 100 validators, if I have 40% of the nodes controlled by myself, then it will become a centralized network. Then it will be a risk to the network. Speed wise also proof of stake is very slow because it needs to solve the problem, but proof of stake is not not that much slow. It is faster. Here the examples are Bitcoin and Litecoin are using the proof of work, but Ethereum and Cardano and there are other lot of Cardano and you can see Algorand. All these are based on the proof of stake. So these are some examples and differences between proof of work and proof of stake. Okay. Do you have any questions here?
No, sir.
Yeah, so we will have some hands-on sessions. I will share the material to you, and also, so these are some problems related to the hands-on. I will prepare a problems based on these exercises, and I will share with you by the end today or tomorrow. I will share with you. Okay. So at the summary, this is the blockchain is the list of the linked list of the hash blocks, and proof of work secures the network via some computational puzzle, and mining is finding the nonce value to meet the difficulty target to satisfy that inequality condition. The proof of stake is just replacing the proof of work by replacing the computational puzzle with the random selection of block proposer and validators. So this is the content related to proof of work and also consensus mechanisms. So, do you have any questions here? You can ask the questions. Feel free to ask the questions, and otherwise, you can even later also after reading this material, you can also post the questions to me. I will answer the questions later also. So,
Okay, sir.
okay. Thank you. These are some references. You can, these are some papers related to proof of work and proof of stake from these are papers. You can search online for these papers and you can read those papers if you want to dig deep into these concepts.
Okay. Yeah.
Okay. Okay. Thank you. So yeah, if you
Thank
have
you,
any
sir.
questions, please feel free to discuss. Otherwise, we can end the session. Yeah.
Okay, done. Arnav, Ayushi, Mannat,
Yeah. Okay.
shall we get going? Close for the day. I'll send you all the details after the session. Yeah.
Yeah.
Yes.
Okay.
Okay.
So we need to send some materials after this.
Yeah, you need to send this material, and also I will share the exercises. I have prepared the assignment already,
Mm-hmm.
but I need to update that. I will share by the end of the today, or yeah, mostly
Okay.
you first share this material so that they can go through these details first before going to
Sure.
the hands-on exercises. Okay.
Okay, I'll send this material to
Yeah.
everyone.
I will
And
share.
yeah, sorry. Yeah. And students, tomorrow make sure you are there on time, everyone. 5:30 p.m. regular time for the master class. Okay. Yes, everyone. Can I have a yes from everyone?
Okay. Yeah.
Yes, sir.
Yes.
Okay, great. Okay. All right, everyone. Bye. Bye. Bye.
Thank you, sir. Bye.